Hey everybody, and welcome back to AI.Code.Cast. We're diving deep into a classic coding challenge today.
It's one that really makes you think,
It really does.
and it involves finding the Kth missing positive integer in a sorted array.
You know, it sounds a little intimidating when you just say it out loud like
I
that,
know.
but it's really not so bad.
It's not so bad at all.
It's actually pretty clever problem solving.
Yeah.
So if you're not familiar with coding lingo,
Yeah.
this is all about finding patterns and thinking strategically.
It's not just about memorizing code.
Exactly.
This is about problem solving.
It is problem solving.
Right.
It's like, imagine you're looking for a missing sock
Okay.
in a perfectly organized drawer,
I like that.
right? But instead of socks, we're dealing with numbers
Okay.
in a sorted array.
Yeah, that makes sense.
So we've got a ton of great solutions submitted by our awesome community.
It's fantastic.
And together we're going to break down this problem.
Yeah.
We'll explore a bunch of different approaches, even the brute force method.
Of course, the brute force always
Always got to start with that.
got to get it out of the way.
And then we'll highlight a particularly elegant solution.
Elegant and efficient.
Exactly.
Using binary search.
Using binary search. So let's dive in and first just understand what the problem actually is.
Yeah, let's make sure we're all on the same page.
Exactly. So let's say we have an array of numbers,
All right.
like 2, 3, 4, 7, 11.
Okay.
And our k value is 5.
All right, so in this case, we're looking for the fifth missing positive integer.
Right. And this array is sorted.
It is sorted, yes.
It only has positive integers.
Positive integers only.
And there are some missing, right?
Absolutely. The first few are missing 1, 5, 6, 8.
So the fifth missing positive integer would be 9.
Exactly. 9.
Okay, got it.
So we're not just looking for any missing number. It's the nth one that's important here.
The nth one. Okay, let's do another example just to make sure everyone's following along.
Yeah, sure.
Okay, so let's say our array is 1, 2, 3, 4.
All right, simple one.
And k is 2.
Okay, so in this case, the array already contains the first 4 positive integers. So the second missing one would be 6.
Ah, okay, so it's not just about what's missing in the array itself.
No.
It's about this sequence of positive integers that could be missing.
Precisely. We have to account for those gaps at the beginning, too.
Okay, now that we know what we're looking for, how would you approach this initially?
I think.
What's your gut instinct?
Well, my first thought is to just go through the array step by step
Yeah.
and keep track of the missing positive integers until I find the eighth one.
Makes sense, right? Just kind of like a manual search.
Exactly. A linear approach, you could say.
But wouldn't that get really slow if the array is massive?
Yeah, that's the problem with this approach. It works for small arrays, but it can become really inefficient for large data sets.
Exactly. So there has to be a smarter way to do this, right?
Right. We need something faster, something more efficient.
And are there any clues in the problem itself that hint at a better solution?
Well, the fact that the array is sorted is a big clue.
Oh, okay. I see where you're going with this.
Yeah, it means we don't need to look at every single number.
So we can use the fact that it's ordered to our advantage.
Exactly.
We maybe use something like binary search.
You got it. Binary search is perfect for situations like this.
I love binary search. It's so elegant.
It is. But how can we adapt it to this problem?
Right. Binary search is usually for finding a specific value,
Yeah.
not a missing position.
That's the challenge, isn't it? We need to find a way to use binary search to pinpoint where the Kth missing integer should be, even though we don't know its value.
Okay, now we're talking.
You're right.
This is where it gets interesting.
So how do we do that?
Well, that's what we're going to dive into next.
I'm excited.
Me too.
We need to shift our thinking a little bit.
Okay, how so?
Instead of searching for the value of the Kth missing integer directly,
Yeah.
we're going to search for the position in the array,
Okay.
where the count of missing numbers before that position equals k.
Wait, so we're not looking for the actual number itself.
No, not directly.
We're looking for where it should be
Exactly.
based on how many numbers are missing before it.
Precisely.
I think I'm starting to see it.
Okay, good.
But how do we actually do that with binary search?
Okay, so let's go back to our first example with the array 2, 3, 4, 7, 11,
Okay.
k being 5.
Right.
Remember, we're not searching for the number 9.
Uh-huh.
We're searching for the position where we've already encountered 5 missing numbers.
Got it, because the fifth missing number will be the one right after that position.
Exactly.
So how do we find that position using binary search?
Okay, well, just like regular binary search, we start with 2 pointers,
Okay.
left and right.
Left and right.
They initially point to the beginning and end of the array.
So in our example, left would be at index 0,
Yep.
pointing to the number
Yeah.
2,
Yes.
and right would be at index 4,
Uh-huh.
pointing to 11.
Exactly.
Okay, so far so good.
Now, here's the key. With each step of the binary search,
Yeah.
we're going to calculate how many positive integers are missing before the middle element of our current search range.
Okay, but how do we count the missing numbers without actually, like, going through them one by one?
Big question.
Yeah.
That's where the sorted nature of the array comes in handy.
Okay,
Because it's sorted, we can use a little trick.
a trick.
A trick.
I love tricks.
Me too.
Okay, tell me.
The number of missing integers before a given element is simply the element's value minus its index minus 1.
Hold on, I'm going to need you to break that down for me.
Sure.
I'm not sure I follow.
Let's look at our example.
Okay.
The middle element of the array is 4,
Right.
and its index is 2.
2, yeah.
So 4 minus 2 minus 1 equals 1.
1, okay.
That means there's one missing positive integer before the number 4 in that array.
Oh, I see. It's because the number 1 is missing.
Exactly.
So we're kind of using the difference between the element's value and where it should be in the sequence to figure out how many are missing before it.
Precisely.
That's pretty clever.
It is, right?
So once we know how many integers are missing before the middle element,
Yep.
what do we do with that information?
We compare that count to our target k value.
Okay, so in our example, k is 5.
Uh-huh.
And we've only encountered one missing number so far.
Right.
Which means we need to keep searching.
We do.
But which way do we go, left or right?
Since the count of missing numbers before the middle element is less than k,
Okay.
we know the kth missing integer must be somewhere in the right half of our search range.
Ah, I see. So we move the left pointer to the right,
Exactly.
narrowing down our search.
You got it.
So the new left pointer will now point to the element right after the middle element.
Yeah, that's right.
And then we repeat the whole process,
Exactly.
find the new middle element,
Uh-huh.
calculate the missing numbers before it,
Yes.
compare that count to k,
Yep.
and adjust the search range again.
We keep doing this until our left pointer crosses over the right pointer.
So when that happens,
Yep.
it means we found the spot where the kth missing integer should be.
Precisely.
Okay, but we still don't know the actual value of that missing integer.
Right, but we're very close.
So how do we get that final value?
To get the value, we use a simple formula.
Okay, lay it on me.
We take the value of our right pointer,
Okay,
add k to it,
right.
and then subtract the number of missing integers we've already counted.
So let's say the binary search has done its thing,
Okay.
and our right pointer is now at the number 7.
Right.
We add our k value, which is 5, to get 12.
12. Yep.
And let's say we counted 3 missing integers along the way during the binary search.
Okay.
So we subtract 3 from 12,
Uh-huh.
which gives us 9.
9.
And that's the 5th missing positive integer in our original array.
Exactly, we found it.
That's so cool.
It's pretty neat, right?
It's like we're using the array itself as a map to guide our search,
I like that analogy.
instead of just checking every single number.
And that's why binary search is so powerful.
It's so efficient.
It turns a potentially slow linear process into a much faster logarithmic one.
So for our listeners who are thinking, why does efficiency even matter? My computer's fast enough.
Yeah, good question.
What would you say to them?
I would say think bigger.
Bigger?
In the real world, you're often dealing with massive data sets.
Way bigger than what you can test on your own computer.
Exactly. Think about, like, sensor data from millions of devices.
Okay.
Or analyzing financial transactions globally.
Yeah, that's a lot of data.
Using brute force on those data sets could take hours or even days to complete.
Wow.
But with binary search, it might only take a few seconds.
That's a huge difference.
It is, right?
So a more efficient algorithm can actually save you time and money?
Absolutely. And computing resources, too.
It's like choosing between taking a scenic route that goes through every small town
Uh-huh.
versus taking a highway that goes straight to your destination.
You get there either way, but one is way faster, especially for longer distances.
Okay, so the big takeaway today is that binary search is a super versatile tool. It's not just for finding a specific value.
It's about reframing the problem and thinking about how we can use it to find counts or positions.
Exactly. And that can make a huge difference in solving all sorts of problems efficiently.
Now, I have a question for our listeners.
Okay, hit us with it.
Can you think of other problems where you could apply this same approach?
Ooh, that's a good one.
Think about problems that involve finding missing elements or gaps in a sequence.
Yeah, get those brains working.
Use that binary search power.
Well, that wraps up another deep dive into the fascinating world of algorithms.
It's been fun.
It really has. And remember, if you want to keep the conversation going,
Yeah?
head over to the AI.Code.Cast forum.
Share your solutions.
Discuss ideas.
And learn from each other.
Until next time, happy coding, everyone.